Where did we finish? So we just finished doing the universe of assets. So the universe is the things you want to trade with. You don't want to trade with everything. Commodities, stocks, bonds, futures, all these other fancy things that we'll probably learn about. So we filtered for primary shares to create a universe. And the next thing we're doing, we're defining a factor. So the factor is something you calculate. The raw data could be close prices of some stock, and then you use the factor to calculate some moving averages, for example. So in this example, they're importing equity pricing from data. So that's prices, as you'd expect. Before we were importing metadata, and metadata is stuff like what stock exchange is it on? Is it primary or secondary? And all that kind of stuff. And then, fundamentals was stuff like market cap, I guess revenue, profits, and all that kind of stuff. So in this factor part, what we're doing is we're calculating some simple moving averages. The input is the close price. So we're taking an average over close prices over a number of days, 21 days, and we're doing it again, but over 126 days. So in practice, what does that mean? There's a good picture, I think. A moving average, it's like a smoothing kind of function. So you can see here, the green is our raw data, and it's jumping about all over the place. It's very kind of noisy looking. And here is our 100-day moving average, and you can see it's very smooth. The other way to think about it is as a low pass filter. So this green stuff going up and down is very high frequency. And even a big dip like this, because it's so steep, it's like high frequency. What we're left with, low frequency. 100 days is obviously quite aggressive because you can see it's not really tracking the line very well at all. So if you set this to a low value, you'd follow the kind of pattern a bit more. And if you set this to 1, so a moving average of 1 would just be the price. So it just match the green line. So what they've done in the tutorial is they're setting up 2 moving averages. Okay, so here's another example. It's similar to what we're doing in the tutorial, where we calculate 2 smoothing averages. One is 20 days and one is 50 days in this case. And as I was saying before, the 20-day one more closely follows the kind of obvious pattern in the data. The blue one has a longer window. And when these lines cross, that could be an indication of whether to buy or sell. Kind of roughly gives you an idea of where a top or a bottom is. So, we're doing the same thing, but we've got 21 and 126. Now, what about this momentum thing? They're taking a ratio. They're taking the ratio of the fast one divided by the slow one. So it'd be something like the yellow line divided by the blue line. And I suppose what that does is if it's 1, it's above, and if it's less than 1, it's below. So it kind of normalizes the price. And you're always going to have a value between 0 and, I don't know, something like 2 or 3. Depends on the data. But so that they're calling that momentum. So that obviously this is not physics. It is, what is a momentum? So they're saying it's close today minus close end days ago. Averaged close price minus yesterday's. So basically, Wikipedia doesn't match what we're doing. So we're walking our own path where we're boldly going. And then we're taking a Z-score. So Z-score, what's that? So Z-score is to do with normal probability distributions. So what is a normal distribution? If you took a bunch of people and measured their height, and you plotted height on the x-axis, and you plotted number of people on the Y, and you did that for a very big sample, like 1 million people. If you drew a line through that, you would get a shape like this. And I think part of the reason it's called a normal distribution is because this shape occurs in nature quite often. So like the size of the frogs at your local pond, that kind of thing. But normally people don't want to put the actual number of people on the Y-axis. What they actually want to put is the probability of finding a person of that height if you randomly select them. So for example, let's say over here, ignoring all the stuff on the bottom, this line is like 6'5", so it's pretty unlikely. And you can see if you look along to Y, the probability of finding someone 6'5", if you just pick someone at random, is very low. But what you actually tend to do is take the area of the curve, area under the curve. So if you were to say 6'5" or over, that probability is this 0.0013, so 1 in 1,000. So different distributions have different spreads, and the measure of spread is the standard deviation. The average may be 160, and the spread may only be 5 centimeters. Now, you might just care about who's freakishly tall or short. So to do that, you use the z-score. So rather than giving you a height, it just gives you a number -4 to 4. That's this row here. And the value of +4 means you're probably a giant of some kind. And a value of -4, you might be a dwarf. And a value of 0 is you're pretty typical. A +4 in Scotland might be 190 centimeters or something. But a +4 in the Netherlands, where people are taller, could be like over 2 meters. But what the z-score does is just lets you compare different distributions without worrying about the actual numbers involved. Okay, so that's what we do. So it does a load of work for you in the background. So here's the code for creating the pipeline. So we do all that stuff we did before, set up the moving averages. So the type of these is a factor, because this simple moving average is a built-in factor. And then you set up a pipeline. We pass in a factor in a column called momentum factor. We set up a screen, which is a universe. So the screen, okay, so it's a filter that's applied. What they're saying is normally you don't want to apply a screen because you might want to try different filters on your data. Whereas if you apply a screen, your data will be limited by the screen that comes out. And then if there's something outside the screen you want to look at, you can't. Now, what is a domain? Let's look at the hardcore documentation. We're hardcore. Okay, so in the past, they didn't have this domain thing. What they assumed was you were only interested in US equities. All the calculations are done assuming market hours and holidays for the US. So if you're doing moving averages, you need to skip holidays. So in the past, they only supported US, but now the domain argument lets you specify other things, like Japan or something. So there's a run pipeline function. And it looks like you can put in start and end date, and then they're calling head. So head is this pandas thing, pandas data frame. Always put pandas on your CV as well. It's basically just an API for dealing with big tables of data. So let's run this. Okay, so we've run the code in the tutorial. Now that is a lot of rows of data. If that was daily data, that would be 1,000 years. So each day has a row for every equity as well. So that explains why there's so many rows. Can I look at more data? I'll be careful typing head into Google. Boom, 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 boom. No, it's exactly the same. So this line doesn't do anything. I'm actually feeling too dumb to know why this is. Okay, what I'm going to do is I'm going to ask a question on the forum. We'll figure this out next time.